So today, it's just the next bit. It's multiplying and dividing. And usually, you learn adding and subtracting like first, second grade. Multiply, divide is like third, fourth grade. So in our head, it's already like add, subtract, multiply, divide is how it's harder. But with rational expressions, with fractions, multiply and divide is actually easier because you don't have to find the common multiple. The common denominator is the hardest part. With these problems, all we have to do is first factor it as well as we can, cancel what we can, and then multiply straight across. Multiply straight across. Okay. We're going to take our restrictions. We have to do our variable restrictions. We're going to take them from our final answer, just like we did before. We multiply straight across, and with division, we do the flip trick so that it becomes multiplication. We do the flip trick, and the reciprocal of the second fraction allows us to change the operation altogether. So it's going to be a pretty quick lesson because there's only really two things you have to do. Flip trick I don't even count as something you have to do because you just rewrite it flipped. But the main thing we're going to have to do is factor it as well as we can and then multiply straight across. Okay. So let's look. 2/3 times 8 over x. We multiply straight across. Look how easy that is. We don't need a common denominator. We don't have to compensate all that. 2 times 8, 16. 3 times x, 3x. Nothing more we can do. Done. Okay. It's going to be just as easy with expressions. We have this situation here. First off, is there anything I can factor out, maybe from one of the top, bottom? Is there anything I can factor to make it a little easier? Maybe we can get rid of stuff to start. We see something. Anybody see it? Just right here. Here, I don't see anything else we can factor. X plus 2, there's nothing we can factor. 2x, no. How about this one? What can we factor out? What's in common between these? There's an x in common. So really, if I factor out an x, we'll end up with this x plus 3. Why is that helpful to factor first? Because then what can we do with this one and this? X plus 3, x plus 3? Cancel. Perfect. So then I end up with this. X over 2 times 2x or over x plus 2. So go ahead and catch up to that point because that was the example problem. You guys didn't fill that in. Remember hopping note. So what did I do? I'm always going to factor first. I did that right here. Factor out an x, divide in an x from each term. Remember that it's a big circle, right? You factor, you distribute. You factor, you distribute. It could go in a circle, so if you have to double check, if I multiply x times x squared, x times 3, 3x. Okay. It's just doing distribution backwards. That's what factoring for those kind of things. Okay. So what's next? Multiply straight across 2x squared because this is 2x times x. 2x squared over. Yeah, let's go ahead and watch what I'm going to do. And leave it out for a sec. Whoops. That's 2. The reason I'm leaving it out, can anybody see why I wanted to leave that out? Because on top, what do we have? 2 times x squared. So what do you think I could do? Zochi, what can I do? You got it. No, I don't want to FOIL. That should be a parenthesis there. What should I do? How can I make this easier before it's the final answer? Simplify. And by doing the 2's, 2 up here, 2 down here, 2 over 2 is 1. See it now? So you can always cancel out whatever you can. At the end, we want an answer that's a little more, simplified as much as we can, like this. And then we have to also say that x cannot equal what? Here's going to be our answer. X cannot equal what? -2. The reason why it's -2 is you plug a -2 in there. -2 plus 2, 0, and you can't have it. We're not having it. All right. Okay. Good job. Great focus. All right, how do we feel about multiply? Multiply expressions? Still like this? Okay. If anyone was like this, anybody brave to say, well, what was the crux? What's the hardest part of that? Not sure? It's just dealing with the expressions, probably. Knowing when to factor or not, when to distribute, not to distribute. Here's the thing. We won't know if we can cancel something out at the very end. It won't be as easy if I would have distributed that 2 and just rewritten that as 2x plus 4, right? So always leave it grouped all the way through. And maybe at the very end we'll factor it out or multiply it out, but You see, I left the 2 on the outside because there's a 2 on the top. I'd be able to cancel that out. Remember, this is 2 times x squared. That's what we did. X times 2x. 2 times 2. Yeah, it's all, you can group it however you like. 2 times 3, 3 times 2, same thing. So let's look at this now over here with division. So, same thing. We're going to have the same exact process, except we're going to convert it between division and multiplication by flipping that second fraction. Okay, so if I look here, 2/3 divided by 7/5. 2/3 stays how it is, but we change the operation and we put the reciprocal in its place. Multiply straight across. Remember, multiply is the easy one. We multiply straight across. 10, 21. Can't do anything else. We're done. Not so bad. So, again, we're going to try to factor as much as we can. I want you guys to work on this problem and double check with your neighbor in the next minute. What can we, you don't solve it all the way out, but what can we factor to make it a little bit easier, maybe chop some things out to start? So let's do this like a minute or so and check with your neighbor. If you have no idea where you could factor, maybe ask your neighbor, what can I factor? Forget about multiplying or flipping it yet. Just like, if I could factor this, I would factor it into something. Call me over if you're not sure.
What do x times x cancel the x squared?
Not even. We're not going to do that though.
Or not?
No, because what you're
So
suggesting.
yeah, so like, yeah, that's what I was thinking.
Well, what's your?
Oh no, never mind. I forgot to distribute it at the bottom.
So say what I heard. Maybe I didn't hear you full, but what I heard was this.
Yeah.
And you'd be able to cancel the x squared.
Yeah.
Now the thing is, this is an entire expression. This is all together. We can't decide to take part of it out. So if I were to divide something out or cancel something, I'd have to cancel it everywhere. Which may happen if you have this, right, over x.
Yeah.
Technically, what you're going to be doing is first take out an x, right? Then you cancel what's on the outside. So we can't decide to cancel that and that. And that's probably the hardest part to like grasp that. So we'll keep doing it. How do I explain it? I've wrestled with that. I'm not totally sure yet. What do you think? Where are we going to factor? Top left, bottom left, top right, bottom right. Where do you think we could factor? Top left, this one. Bottom left, this fraction, top. Bottom. Anybody have an idea? This one we would be able to distribute it back, but that isn't going to be helpful. Remember, when it's grouped like this, we like it because that's where we can cancel things out. So what I'm going to suggest is do the x method for this trinomial on top. What multiplies to give us 6? Adds to give us 5? There it is. So I can do this, x plus 2, x plus 3. All I did was convert this trinomial into those two. Right? Why was that helpful? Why do I want to do that? Like, I know I did something right, because what can we do now? Cancel. X plus 3, x plus 3, you see. So always think about it this way. You put on, again, that test maker's hat, like how they're designing these problems. When I saw this x plus 3 on the bottom, I knew actually off the bat that this trinomial was going to have one of the expressions going to be x plus 3, because that's what they want you to discover as well. Start to see that a little bit, and it'll help you know where to start if you're not sure. So we end up with x plus 2, 2x, divided by x minus 9, and then 2x. It doesn't even matter if we have common denominators. We don't care. It's division / multiplication soon. So now get to this step and then do the next step. Do the flip trick. We get to change the sign, or excuse me, change the operation. First one stays the same. Go ahead and rewrite that second fraction. All right, what goes on top? 2x. On the bottom, we have that x minus 9. I'm going to keep everything in parentheses, and as I multiply across, I'm not going to distribute anything. Okay. In fact, Let's leave everything factored, always. There's no reason for me to distribute that out, because then I won't know if I can slash some more. Right, so let's see. 2x times x plus 2. 2x times x plus 9. So we'll play a game this way. Anytime you see what's called like a crux, what's the hard part? If you can verbalize that, Starburst or Kit Kat. Okay. Adriana?
Trying to figure out which ones to factor out.
More specifically within this problem, where does that happen? Where was it hard like that?
Probably when we did the X method, like
This.
to see what would work to factor it out.
Okay. So regardless of the problem, if I had this trinomial, right, I would use the X method to put it into binomial. So that's going to be the process anyway. But the what we're going to factor out, what we can cancel out, is actually just whatever's in common on the fraction. So it's going to be that way every single time. Trinomial to 2 binomials. I was able to cancel a binomial there. Good job. Oh, Yanni. No, not Yanni. Right here. That was the worst throw of the year. It's televised. Now the world knows I'm a bad thrower. All my Brazilian watches. There's only one. What can we cancel out now? Cancel 2 x's, right? You can even think of it as 2's and the x's. And x plus 2, x minus 9. Let's go ahead and put what x cannot equal, and we're done with this. X can't equal 9, right? Look at the bottom of the fraction. That's what we care about. X can't equal 9. Anybody else have a crux? Or like where it gives you a headache? The whole school?
Yes.
Okay. Hey, me too sometimes. Yes. Yes. I feel you. The glare's weird, the lighting's weird too today. Yeah, a little bit, huh? Kelly, can you close that? Whoa. We're vampires. All right, let's do one last problem. I'll set you loose on the classwork. All right. All right. Let's rewrite these. I'm going to have you, there's nothing we can do about the second fraction. There's nothing we can factor out there, right? So my clue, anytime you see the same thing, in both terms, you could factor that out. Now just remember that x squared is x times x. 3x is 3 times x. So what I can factor out from those, or what's in common, I can factor 1x out. So you see, expanding might be helpful if you're not sure what to do. Okay. So the crux questions you guys come up with, it helps me to see what I can re-explain. So you see, x squared minus 3x is just x times x minus 2. You want to close the whole thing? Yeah. Jair, can you close the curtain and keep it attention up here? All right. Should we do that? Sam, can you hit the very right switch? Just for a moment. I don't like that either. How about this one? X squared. X. We have a negative 6. We have a negative 1. What multiplies to give us negative 6? 2. Negative 3. Will that give me 6? And that adds to give me negative 1, right? So what I know is this is going to be x plus 2. This is going to be x minus 3. Look what happened. Whoever designed this problem had this in mind, right? What can I cancel now?
X minus 3.
There it is. All right, we have x over x plus 2. Let's do the flip trick. We flip that up, side down. Change the operation. Put the reciprocal for that second fraction. Let's multiply straight across, leaving them in groups, so that I'm guessing something's going to give. It's not x. All right, last bit, last thing, second to last. Cancel that. All right, we know that x minus 3 is on the bottom, so we're going to have x cannot equal. Thumbs up, sideways down for this one. Teetering. Okay. Okay. It just is something different. Remember, keep your confidence up. It's easier than yesterday. We can do that. Anybody have any shout outs, any birthdays, anything? Is your what? It's your mom's birthday. It's Arshana's birthday. Happy birthday, Arshana's mom. Let's do a happy birthday, Arshana's mom on 3. 1, 2, 3.
Happy birthday.
Arshana's mom. Happy birthday. We're singing.
Oh, we sing.
No. Right after you email to her, that'd be useless.
Oh.
All right. Thanks for watching.